Hi there, this is the RPS Project. I'm Richard, and today I'm going to have a look at the Darlington Pair. Now, the Darlington Pair is just two transistors designed to get more gain, current gain from a BJT. So this is the basic circuit, basic diagram. Doesn't look much, it's very simple, it's easy to set up, and hopefully once I've had a look at this I'll have a better understanding of how to get a bit more current gain from a couple of transistors. So let's get and have a look at it. So here we have on the breadboard my circuit set up, a couple of transistors. Now what I've actually got is this. This is two transistors together as a Darlington pair. Now I've used two different transistors. Supposedly they're meant to be the same, but well, I'm not worried about equal gain or anything. What I want to know is can I get a lot more gain by having two transistors in this configuration? So this is a BC337 and this is a ZTX651, I think, something like that. Can't quite remember without looking at it. And then obviously biasing this thing up. If I was going to have a signal in, I could have a signal in there, but I'm not. I'm just going to have some voltage there and some current. Now I've got a 1k resistor there, and I think this is actually a 220 ohm resistor. Now these two resistors, let me just have a quick look at me notes. I've actually put as, now 12, that's 1.2, this is actually about 12 ohms and this is about 1.2 ohms. So yeah, they're quite low resistances, but it allows me to get a lot more current. And I suppose if you wanted even more current, you'd change these resistors. Actually you'd have your load, whatever your load is that's going to be there would be in that point, you know, super bright LED, motor, some other device, you probably have your load in that point, I suppose. Be the reason for having the current there, and that's basically what I've got. So what am I going to measure? Really, I'm going to be measuring a couple of places. I'm going to measure the current out there on the base. I'm also going to measure the current here on that base, but I'm also going to measure and have a look at the current. Of course the current on that base is the emitter current from this BC337, and the current coming into the transistors. I'm actually going to split this up. I'm going to look at this at 3 points. I'm going to be looking at it from this point here, this point here, but also this point here, because really they're going to be three different values, or at least this one will be definitely different from this value, even though that'll be basically pretty much the same, because you need to have obviously a certain amount of current coming through here once this transistor is turned on, and that's going to be added to whatever we get out from this side. Not to mention I've also got to add more than one voltage drop for this turn on here than I would normally have for a transistor, because I've got two, so I've got to have at least probably about, what, I don't know, 1.4 volts there. So if I think I worked out that I was going to put something like, well, what have I put, 2.2 volts I'm going to put on there, which is more than enough. So yeah, let's start looking at this. So let's turn some things on, get some things set up. Now in my first configuration, because I'm going to do a couple of them, I'm going to use a resistor divider on the for the base current. So let's get these couple of resistors in. That one needs to go just that, and that one needs to go there. Then what have I got these things set up with? That's my that's a lot. It's going into the base. And this one is coming from where? Ah, there. Right. So yeah. So this one is currently going to be looking at the current coming in onto the base there, whereas this I've actually put in the bottom here, so I can see, even though I said I'm going to look at the current there, I actually want to see the total current. So it's almost the same at these 2 points, only I've got a little bit more current coming through from this point, so it will be a little higher, but hey, let's take a look. So hopefully we can see those multimeters. What's the trouble with my spaghetti junction here is I worry that I'm going to short something out, but yeah, so, well, I suppose I better turn it on really, aren't I? Let's see what happens. Flash and a bang, I suppose. Worst case scenario. And that's come on. Yeah, brilliant. Now I've got, as I was expecting, about 7 microamps at that point there. And this is what's going into the base. Now, because I've got a resistor divider, I expect to actually get about 10 milliamps across that resistor divider, but the base of this is only pulling through about 7 microamps, because that's all it needs. It's just going to take what it requires for it to turn on. But on the output, this is on the 10 amp range, because you know, multimeters, especially these cheaper ones, you know you get, and this is actually quite a nice one, this Draper, despite being at the lower end. It is a nice little multimeter. I digress, but you get a 200 milliamp range, and then it jumps up to either like 5 amp or 10 amp on this one. So I've had to put it on the 10 amp range, but that means I've got 570 milliamps. I put in 7 microamps. Now I could do the calculations for that, which I have actually already done, because I was having a look at this before to make sure I get it right. That comes in at about 90 odd thousand. It's nearly 100,000. I mean, if this settles down, that'll probably go up as these transistors warm up. I'm expecting that will probably go up a little bit. So, you know, in theory you could end up with 100,000 on the gain. At the moment it's not quite that, you know. I've got, well, basically, well, we can see, can't we, if I just take we'll do it the simplest way, 0.58 divided by 0.000007, that's 82,857 on the gain. But I mean, as I've been testing this circuit, I've had a gain of 100,000. You could never get that from a single transistor, it just wouldn't happen. So that's a massive amount of gain. Anyway, I did take other measurements. Like I say, I actually took measurements of this on the current at the base of the second transistor and the currents into the individual transistor collectors, just to see what I was getting. And from this one, from the first transistor, you got about 6-7 milliamps in there, and the collector current was 1.8 milliamps coming in here. So obviously I'm going to get just a little bit more coming out there. So the base, onto the base of T2, I was getting 2.6 milliamps, but that 2.6 milliamps is relating to 590 milliamps through the transistor. That's just loads of gain. That's great. Now what I'm going to do is I'm going to change the configuration very slightly, and I'm going to put in a single resistor on the input So I'm going to force in whatever it's going to be on there. I'm going to say you're going to get this much current on the base, and then see what I'm going to get on the output. So I'll just change that over and see what we get. And of course this resistor will change. I'm going to be putting in the two different values I would put in is something huge, starting with 106k km resistance, and then I'll put a slightly smaller one so I get more current on the base. I'm going to put in 10.6k. It sounds like I'm being illogical here, but actually it works out more to what I've got available, so that's what I'm going to shove in on here and see what I get out of it. So I've changed my resistors over. I've now got a configuration that's much more like this. You can see I put a big ass resistor in there so that I can limit what current goes onto there, but it's more current than I was getting with the resistor divider. I'm actually expecting to get something in the range of about 100 microamps onto the base, which is a lot more than the 6-7 microamps I was getting before. But what am I going to get through here? I am limited obviously by the two resistors I've used, but I'm hoping I'll get a bit more, something in the range of 700 or 700 and I don't know, at least 700 milliamps, but I don't know exactly what I'm going to get until I test it out. So let's turn this one on and have a look. Actually, as you can see from this, I've got 82 microamps now on the base. 83. It'll probably warm up a little bit, but with this 82 microamps I've got 660 milliamps at the moment on the emitter, which will probably be about the same on the collector of the second transistor. You know, 660 milliamps here, but with 82 microamps here. So I've actually not gained a lot by doing this. What's the gain on that? Let's have a quick look. I don't know if you can see this calculator very well. We've got 0.66 divided by 2308. Did I say? Gives me a gain of about 8,000, which is not bad. That's really quite good, but not as good, anywhere near as good as the gain I was getting with the 6 microamps on the base. Even though my output, it was less, it wasn't massively less. So what I'm going to do is I'm going to change this setup again. I'm going to change this resistor. I'm going to make it 10.6k and force a bit more current into there, actually quite a lot of current, and see if it really gives me much gain. Again, yes, I'm limited by the resistors I've used. I just want to see what happens, see if I can make it work a bit more, get a bit more out of it. So let's change those resistors over. Okay, so I've changed the resistor over now. I've got 10.6k in there, so I should get more current onto the base. So let's see what that's going to give me. Yeah, definitely got more current on the base now. 800 and something microamps. I mean, I was expecting maybe the 1 milliamp, but obviously the spaghetti junction takes out a lot of stuff. So yeah, 815 today with 670 microamps. So really I haven't really gained anything on the output. I suppose I am to some extent limited by what I've got here. So no matter how hard I try to turn on, I try to put into this circuit, I can only get so much out because it's limited. So really it seems to work best if I've got a really small current on this side. I mean, once you get into like nearly 1 milliamp on there, then you're just into the basics of what one transistor would normally be used for. So why do I want all the gain if I've got a decent current coming in there? It doesn't figure. So this scenario isn't really reflective of what I'd want to use this Darlington transistor for. You know, yeah, I've got quite a bit of gain there, quite a bit of current there, but I've got loads of current coming out. But the best scenario was with the smaller amounts, with the other circuit, with this resistor divider, 6 microamps, 7 microamps on there, and about 580, something like that on the output. So the gain was phenomenal. Phenomenal. Can I say that today? Can I? Dear, oh dear. Phenomenal. Never mind. Yeah. Very small input current, huge amount of output current, and you're only limited really by the factor of what your load is going to be, what you're going to have in here. I suppose that's what you've got to be careful of. You want to limit, you're going to put the appropriate resistor in here to limit it so that your whatever is going to be there is going to get the right amount of current to make it work. And then you'll have a really great circuit for, I don't know, a switching device, as long as it's not high frequency switching, because there are drawbacks with this configuration. High speed frequency switching doesn't tend to work. Low speed frequency switching, yeah, work fine, I expect. Something there's a motor maybe you want to turn on, it's got to have a lot of power, so you might turn it on once and then it's turned off a bit later on, but it's turning on and off, but not fast, not a quick turn on and off. Fine, I know, high powered LED, not really sure what you could use it for, but I mean it is used quite a lot. Darlington Transistor Pair does what you want it to, gives you lots of current gain. So there you have it, the Darlington Pair. Quite a simple device, very easy to set up and easy to understand really. I mean, basically I managed to get out a lot more current than I was put in. Like the first setup I put in 6 microamps, managed to get out 610 milliamps through the circuit. That's nearly a gain of 100,000. I mean, each individual transistor, you'd never get that sort of gain, even though some transistors, you know, you've got 300, 400 on the beta for its gain, you know, but for me, you wouldn't normally get 100,000 gain. Second circuit, not quite as impressive, but I mean 82 microamps put in with 680 milliamps coming out of it. That's really good. It's a gain of 8,200 plus more. Now the third one, I didn't get the gain I was expecting, even though I was trying to put in more current onto the base. I put in 845 microamps, or about that, you know, getting out about 700 milliamps. It's a gain of about 800, 820, something like that. Now, obviously, I'm restricting myself with what I use for the resistors on the collector and the emitter. I mean, in theory, I suppose you'd have your your load on that side, so whatever your load is, whatever your load's going to need, require, whatever you want to get out of it, whatever your gain needs to be, you'd obviously set that up and bias it up to be appropriate for whatever you want. So I've obviously limited myself to a certain extent with the resistors I used to get a current through the second transistor. So, you know, the gain is still massive, especially when you're using a really small input, which I suppose is what Darlington Pair is designed for. Now, in my circuit, I just used any old transistors. I got 2 different ones. Now, supposedly, you're meant to use matched pairs, so you'd have 2 transistors that have got the same gain and all the same characteristics, so that the multiplier for the beta is the same. So, I mean, if it's a gain of 100 on the first transistor, you've got exactly that same gain on the second transistor, which is what they're supposed to be, a matched pair of transistors. Now, buying matched pairs can be quite expensive. It's easier just to buy a bunch of transistors and then go through them yourself and get the ones that are as close to each other as they should be. Saying that, you don't have to buy matched pairs. You could just buy one of these. This is a TIP 120, TIP 120 I call it, but there you go. It's a Darlington transistor all-in-one package. Comes in a TO220, is it? Package, and works really quite well. This thing can get up to, say on the front here, says it's a TIP 120 Darlington NPN 60 volt 5 amp. So that's a lot of power. So this thing is going to get warm. Obviously in this package you can bung one of these on, which is a heatsink. So bolt that onto there. There you go. Fantastic. There are some other characteristics and drawbacks with the Darlington. I'm not going into that today. It's not what I want to look at. So there you go. But I've managed to understand, I think, what on earth a Darlington transistor will do. So what am I going to say about it? Anyway, if you like this video, give me a thumbs up. If you didn't, thumbs down. Subscribe, and all comments are welcome.